everyone, welcome to the next session of Strength of Materials. In this session, we will be discussing numericals on spherical shell. A spherical shell of internal diameter 0.9 meter. So value of D is given as 0.9 meter, that is 900 mm, and of thickness T, that is 10 mm, is subjected to an internal pressure of 1.4 Newton per mm square. Determine the increase in diameter and increase in volume. Take E as 2 into 10 raised to 5 Newton per mm square and the value of mu is given as 0.3. I need to find delta D and delta V. The formula for delta D is PD square upon 4TE 1 minus mu. So this pressure is 1.4, diameter is 900 whole square, 4 into T, and E is 2 into 10 raised to 5, 1 minus 0.3. On solving this, I get the value of delta D as 0.09923 mm. Next, I'll calculate delta V. The formula is PdV upon 4TE into 1 minus mu, and here there is a term 3. So V is pi by 6 d cube. So when I substitute, delta V is 3 into 1.4 into 900 into pi by 6 900 cube upon 4 into 2 into 10 raised to 5. This is 1 minus 0.3. So I get delta V .126,248.43. Let's take the next numerical. A spherical shell 1 meter in diameter. So the value of D is given as 1 meter, that is 1000 mm, and 5 mm wall thickness. Value of T is given as 5 mm. Is filled with a liquid until its volume is increased by 200 centimeter cube. So the change delta V is given as 200 centimeter cube. This becomes 200 into 10 raised to 3 mm cube. Determine the pressure on the wall. So I need to find P. Principal stresses, that is I need to calculate sigma C, and maximum shear stress produced. So I need to calculate tau max. E for the shell material is 2 into 10 raised to 5 Newton per mm square and mu is given as 0.3. So I'll start with calculating the pressure P. Now for that I can use the formula of delta V, which is PdV into 3 upon 4TE into 1 minus mu. Here I can substitute 200 into 10 raised to 3 is equal to 3 into P, D is 1000, V is pi by 6 into 1000 cube upon 4 into T, E is 2 into 10 raised to 5. And here I have 1 minus 0.3. So on calculating, I get the value of P as 0.7276 Newton per mm square. Now once I calculate P, I can calculate sigma C as PD upon 4T. So this becomes 0.7276 into 1000 upon 4 into T, it is 5. So this becomes 36.378 Newton per mm square. This is the hoop stress, which is also the principal stress that is asked. Now there is nothing called as sigma L over here. So when I calculate tau max, this is sigma C minus sigma L by 2. So this is nothing but sigma C minus sigma C by 2, that is tau max is 0. Because this is equal to sigma L, which is equal to sigma, I can say. So here this is directly substituted. I hope you have understood the numericals of this topic. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to my channel. Hit the bell icon for latest updates of my videos. See you in the next session with another topic. Thank you.